Are you phasing through trees in your Unity game? Then you are experiencing a common problem with Unity terrain trees. Let's learn how to fix it today. Come down to LewyT Game Lab where you and your ideas will learn to create digital life. Well, at least bring the trees back with the antidote for their phantom physics. If you watched my LewyT Amusement Academy Part 5 and followed along painting a forest of trees all over a large terrain, you may have seen an issue I failed to mention in that video. When you entered the play mode with your character and walked around, you might have discovered that some trees are messed up. They look fine, but you can walk right through them. Now, I triple checked the settings. The tree prefabs themselves have box colliders, and the terrain collider component has enabled tree colliders checked. Everything should be working, but still this issue persists for some of my trees. If that bothers you in terms of realism, or if you want to use trees with colliders as a form of obstacle, I'm sure you can see the problem. Why does this happen? I've heard some theories, and I'm not an authority on the subject. I don't want to speculate on the exact details, but it comes down to some built-in limitation of the terrain collider system. I don't think it's a hard limit of the number of trees you can have, but it may be related to the size or complexity of the terrain. All I know is that in my experience, the default terrain seems to only handle about 50 tree colliders. You can add all the trees you want, but only about the first 50 work as colliders. It seems that once you hit this limit, that all trees you paint after that are missing their colliders. This means any character or object that should be blocked by the trees can pass right through them instead. So how do we fix it? So there's a few alternatives. The first, maybe we just don't paint more than 50 trees. If you've run into this issue, that probably doesn't seem like a reasonable solution to you. Or we could just paint all the important trees first, and then you can have all the unimportant trees that don't have colliders. But then if you want to add more important trees later, then you have to start over from scratch. So not fun. Another option might be to manually add invisible collider objects. If you are using a mass of trees as a border of your game level, this might work as an invisible wall placed to line up with the trees. This doesn't address any individual trees that you want to have to walk around unless you manually place individual colliders for each lone tree. And this defeats the convenience of using the terrain tree system. You might as well do option 3, which is manually place game object trees instead of using the tree system. This can work in combination with option 2, but it is a lot of work if you have a lot of trees. Okay, another option, give up on Unity and throw your PC out the window. Don't do this. There's one more option. We can have a script that can handle adding colliders to all the trees automatically. I'm a coding person, so I like this idea. The C# solution for bypassing the terrain collider limit was developed with AI assistance from Google's Gemini model. I analyzed the code and confirmed it worked with minor adjustments. Okay, so here is the code. It's a regular monobehavior script. It only needs one using statement, and it needs one public property. That's the terrain, and there's a start method that calls another method, and this is that method, generate colliders. The first thing it does is just checks to see that that target terrain is populated. If it's not, it won't go do anything else because that would cause errors. Then it gets the terrain data from that target terrain, and then it gets the tree instances from the terrain. So that's all the trees, whether they have colliders working correctly or not. And then it gets the prototypes of the trees, and what that means is, let me show you real quick. So when you're in the terrain and you go paint trees, this list, I called it a palette one time. This is the prototype. So it's just like one of each kind of tree that you want to add to your terrain. So here we go. We got the prototypes, and it's just a list, an array. And then the collider count is just a number that we're counting as we go through all the colliders, all the trees really. And then this is the terrain transform. So every game object has a transform. And so this is the transform of the terrain game object. Then we loop through all the tree instances that we got from the terrain. And each one of those, we just call it instance. And it has a number of properties, one of which is prototype index. So this is how we check to make sure that the prototype is valid. And then we get the original prefab. This is what we use the prototypes for, to find out the prefab that the tree is made from. So it's prototypes, instance prototype index dot prefab, and that we store as the original prefab. Then we create a new game object. We're just calling it collider host. This is really the only place we use that collider count is in the name of the collider of the game object. And then we make sure we set this object in the same position and scale as the tree that we found. And so we're using the instance.position, size, the train position, and the scale is the scale of the tree. And then we set this host's parent to this.transform. And this.transform is whatever the game object that we're going to apply this script to. And then we run this other function with the original prefab that we found and collider host object. And then we increment by 1. So here's this method, copy collider from prefab. And it wants that prefab and the game object. And then we get the collider component of the prefab. And if for some reason it's null, then we skip out, because that will cause an error later if we don't. Return. And then if it's not null, then we can check to see if it's one of these different kinds of colliders. So I've got a switch case statement, original collider, and then we're comparing it with, is it a box collider, a sphere collider, a capsule collider, or a mesh collider? And that's pretty much all the collider types you would expect to see on a tree, I think. So in each one of these, you've got a specific case. So for a box collider, you add a box collider component to the host object. And sphere collider, so is the same thing. You just add the sphere collider. For capsule collider, you add a capsule collider. And mesh collider, you add a mesh collider. And then each one of these colliders have their own special properties that have to be set. The box collider needs a size and a center. A sphere needs a radius and a center. A capsule needs a radius, a height, and a center. And then a mesh collider just needs the mesh. And I think it's a good idea for it to be convex. And then that's it. So basically we're going through all the trees. We're creating an object for each tree, and we're setting it, giving that object a collider and making sure it matches the prefab that it came from. And that's everything. So let's go ahead and test it out. So the main thing that we need to do is create an object. It can be an empty, and you can name it anything, but I like to call it tree colliders, something like that. And then I'm going to add the component, and I'm looking for that tree collider generator script. Added it on there. Now that's not everything that we need to do. We also need to populate the terrain. So we're going to go drag the terrain from the hierarchy over to this target terrain slot. And that's it. Let's run the game and see if we can run into some trees and rocks. Okay, so previously we could run right through these trees. Now we're running into them. The rocks seem all solid. So everything is solid. That's the plan. That's what we wanted. Okay, I wanted to point out a few more things. So when we're in play mode and we look at the tree collider object. It has children, so we open that up. And here is all those colliders that we created. There is 858 of them, starting at 0, so it's 859. All these numbers come from that script, so let's look at the script again. I wanted to show you this line that says collider host.transform.parent equals this.transform. That is what puts all of these new objects as a child of the tree collider. I mean, the tree collider's object. It could be, it doesn't have to be called that, but these are all called tree collider and then a number, because that's what this this line does. It creates the objects and it gives them a name, tree collider underscore, and then the current count. So as it's creating them, it's counting up as the collider count plus. And so that's why you get all these different named objects with a different number, basically. So that gets all of them. So that means that's 859 individual terrain tree objects that I've created in this world. And as you can imagine, that's a lot, but it still runs pretty smoothly, at least on my computer, and even in the editor. Whereas if you were to build it, it would probably run a little bit smoother. But at some point, this technique might break down if you just simply create so many objects that it's too much for the engine to handle. Another thing I wanted to mention is that the way I've got it set up is in this script, it's running this code on start. So it does not generate these colliders until the game is already playing. This works fine for creating the colliders, but it's not really compatible with a game that uses navmesh. If you use a navmesh agent in your game, these colliders don't exist. It won't use the colliders to know where to go around them. So that could be a problem if you're relying on navmesh. So the navmesh characters will either go straight through the trees or attempt to and maybe get stopped. The system I'm using for my characters are not navmesh. I'm using a more simple system. Thank you for watching LewyT Game Lab. If you learned something down here, please like this video or subscribe to my channel. Share it with your friends, frenemies, enemies, and even your nemesis. I hope to see you back in my lab next time, where you and your ideas will learn to create digital life.